Welcome to our channel. Today we are going to see about capacitor in details. Capacitor is an essential component in electronics. We cannot find a circuit without a capacitor. Before the start, we like to intro about us. We have about 8 years experience in electronics design and development. Please subscribe this channel and press bell button for instant notification for new videos. Capacitor is a simple two-terminal device. Terminals are metallic plates and there is a dielectric material, such as mica, paper, glass, etc., which are insulators between them. Whenever voltage is applied across its terminals, also known as charging of a capacitor, currents start to flow and continue to travel until the voltage across both the negative and positive, anode and cathode, plates become equal to the voltage of the source, applied voltage. Capacitor comes in different shapes and their value is measured in farad. Capacitors are used in both AC and DC systems. Water analogy is an example for working of capacitor in AC and DC systems. The capacitor blocks DC signal. But in case of AC it allows. Let's discuss in detail. Capacitor performs 3 tasks in DC circuits, i.e. taking charge, holding charge and delivering charge at certain time. When capacitor is connected to DC voltage source, capacitor starts the process of acquiring a charge. This will build up voltage across capacitor. When capacitor has almost full voltage across it, no more current flows through capacitor. Henceforth capacitor start blocks DC signal. But there is an interesting fact. The capacitor will not acquire 100% charge at same instant when DC voltage is given to it. The capacitor gets first part of total charge quickly, second part slowly, third part more slowly and so on. Hence we can say that capacitor charges non-linearly. The insulating medium in between the two conductive plates of capacitor opposes to the flow of current. This change creates an effect which stores in capacitor in the form of electrostatic field. The capacitor is connected directly across the AC supply voltage. Let's consider a single cycle of positive and negative. In positive cycle the capacitor starts charging until it reaches the peak and become equal to the voltage of the source, applied voltage, as in first diagram, then start decreasing. In negative cycle flow of electrons is in opposite direction to positive cycle, which is shown in second diagram. As the supply voltage increases and decreases, the capacitor charges and discharges with respect to this change. A current will flow through the circuit, first in one direction, then in the other. When voltage applied across the capacitor, it stores the energy in dielectric medium, which is present between two electric plates of capacitor. Amount of charge stored in capacitor can be calculated based on this formula. Charge equals to capacitance multiplies voltage. The main difference between a battery and a capacitor is that battery stores charge in the form of chemical energy and convert to the electrical energy, whereas capacitor stores charge in the form of electrostatic field. Capacitor storage is less and charge/discharge is fast. In case of battery it is quite opposite. That's why we can see capacitor in all the circuits. Let's see the polarized capacitor with real-time image and symbols. Usually electrolytic capacitor has the negative that is labeled with a negative sign. Tantalum capacitors have a positive sign or a band on the positive lead. Plus or minus of this capacitor cannot be interchanged. If interchanged, it will result damaging the capacitor. Sometimes it will burst also. Let's see the non-polarized capacitor with real-time image and symbols. That's this type of capacitor are bidirectional. Can be used on either way. Let's see the variable capacitor with real-time image and symbols. Variable capacitors whose value alters when you vary, either electrically or mechanically. Mainly 2 types. Tuning capacitors and trimmer capacitors. Let's see the application of capacitors. To smooth the wave. Frequency filters, high-pass, low-pass filters. Power factor correction. Coupling and decoupling of signals. Motor starter. Snubber, surge absorber and noise filter. Oscillators. Now we are going to see the types of capacitors. Electrolytic capacitors. Generally, electrolytic capacitors are polarized. They are able to offer high capacitance values, typically above 1 microfarad, and are most widely used for low-frequency applications, power supplies, decoupling and audio coupling applications. Next we'll discuss about ceramic capacitors. A ceramic capacitor is a non-polarized. Their values range from a few picofarads to around 0.1 microfarads. Used as bypass capacitor for high-frequency signals. Next we'll discuss about film capacitors. Film capacitors are non-polarized capacitors with an insulating plastic film as the dielectric. Film-type capacitors are available in capacitance ranges from as small as 5 picofarad to as large as 100 microfarad. The variable type of capacitors can vary the capacitance value by changing the distance between the plates or the effective area of the capacitor. Air gap capacitors. These capacitors use air as the dielectric medium. Vacuum capacitors. These capacitors have glass or ceramic encapsulation and vacuum as the dielectric. Calculating value of capacitor. A number code is often used on small capacitors where printing is difficult. The first number is the first digit, the second number is the second digit, the third number is the number of zeros to give the capacitance in picofarad. For example, 102 means 1000 picofarad equals 1 nanofarad. 473J means 47,000 picofarad equals 47 nanofarad. J means 5% tolerance. Let's see the application in details. In rectifier circuit for smoothing the wave. In this board, you can able to see 4 electrolytic capacitor are used and 2 ceramic capacitors are used. In this use, the capacitor charges up when the peak voltage exceeds that of the output voltage, and supplies charge when the rectifier voltage falls below the capacitor voltage. Electrolytic capacitor are used as energy bank, which smoothness the curves DC. Ceramic capacitor are used to reduce the noise present in the power supply. We might have seen the capacitors in many places like ceiling fan and an AC compressor. In this case, capacitor is used to start the motor. Is your fan running slowly than before? Mostly it due to the capacitor. Capacitance value in the capacitor might have been reduced after a while. In most of case changing the capacitor will solve your problem. Dual-run capacitors are commonly used in HVAC, heating, ventilation, and air conditioning units. Dual capacitors have 3 terminals, unlike regular run capacitors, which have only 2. Electrically, they are the same as run capacitors that have 2 terminals. Using a dual-run capacitor allows you to save space if you have a small mounting area. This is an audio amplifiers board. You can able to see so many capacitors are used here. The big electrolytic capacitors are used as energy bank for the board. Whenever the amplifier requires more power, this capacitor provides this additional power. For example, when playing song, if a deep bass comes, then the amplifier draws more power. That time this capacitor will be useful. Ceramic capacitor are used for low pass and high filters. Thanks for watching. Please subscribe for more technical videos.